All right, let's do that. Welcome.
This
My
is a
presentation about
demonstration
how
of
2 years ago I
Wirecast.
made a FM synthesizer for my bachelor's thesis. I want to talk a little bit about what's the basics and how can you get started if you want to achieve a similar project, use it musically, or well, just as a hobby or experimentation. So let's start with a little audio basics. We all know music. It
This
consists
is
of
a
tones,
demonstration of
expressed as
Wirecast.
sine waves. Well, very easy. Everybody knows these things. The most important things are like the speed, from in which it goes from one to the next phase or iteration, and amplitude, which is loudness basically. In audio programming then, you will have always a bit of latency, so you will use a buffer to compute
This
the
is a
next,
demonstration
say,
of Wirecast.
128 samples of audio, or maybe more, depends on how heavy the computation is that you need. The main thing about this audio programming is that you don't want to skip a few samples in your buffer. If you have an empty part in your buffer and the computer was not able to compute the output fast enough, then you will just have a glitch. And in any kind of live
This is a
situation,
demonstration of
you cannot have
Wirecast.
that. Like just like a DJ would have the whole room fall silent. Well, that's kind of the end of the party if it takes too long, and well, you don't want to hear that stuff in your live performance. So the conclusion of that is you cannot do any expensive operations, no instantiating new objects in the audio thread. You want it to be just as simple
This is a
mathematically
demonstration
computations
of
as
Wirecast.
you can get. So simplifying everything in the process that goes from input to output is very, very nice for your performance in the audio plugin. What's more, so because we're working digitally here, we're doing, well,
This
discrete
is a
time
demonstration
and
of Wirecast.
which I say I can draw this like a full-on line. Looks very nice. Actually, of course, in the computer, it will just have a discrete amount of timestamps, really, and a discrete level of how high the amplitude is at that point. So, like that. And then when that signal goes out through the speaker,
This is a demonstration of Wirecast.
Of the digital to analog converter to make a nice oscillation out of that sequence of signals. Of course, the denser these intervals are, the higher quality audio you can say. But that comes to a price. Of course, you need, if you want to have the sample rate twice as high, you will have to do twice as many computations. Same goes for
This
if you want
is a
stereo sound, you
demonstration
have two
of
channels, you have
Wirecast.
twice as many computations. Those kinds of things you have to take into account. So since I'm talking about audio plugins, some of you might not know what that means. It's very much akin to how one could develop an extension for Firefox or something like that. So musicians use audio software called a DAW, Digital Audio Workstation, and they all conform
This
very
is a
much
demonstration
to
of Wirecast.
a few standardized types of plugins. So you have VST, you have AU, and some more. And that's pretty much like an API. So if you program against those promises, then you can be pretty sure that it will work in the most popular DAWs. Thing is, of course, there are multiple of these libraries, so VST and AU.
This is a
you
demonstration of
want to have one
Wirecast.
thing that works everywhere. So that's where JUCE library comes in mainly. It will allow you to abstract away from all those libraries and program against a JUCE API so much that it will work on Windows, Mac, and Linux, and it will also be multi-platform, so it will be usable in a vast range of audio workstations.
This is a demonstration
Okay,
of Wirecast.
so a little bit more. Let me take a breath. About some starter stuff in audio software. So you could think of 3 kinds of effects, which in this way, in this order, are a MIDI
This
effect,
is a demonstration of
synthesizer,
Wirecast.
and an audio effect. So the first one, MIDI effect, will transform your playing keys into different keys, or play the same keys in a different time, or repeat those keys, or make a scale from one key. All those kinds of effects you could imagine. The second type is probably most, well, not most common, but the most simply understood for anyone. You play keys and it makes a sound. Yeah, so there's different kinds of data. So the keyboard
This is a demonstration of
symbolizes
Wirecast.
MIDI data, and the waveform symbolizes audio data. Last one is an effect that would transform audio into a different type of audio. So that would be a distortion plugin, delay, all kinds of audio effects you can imagine, filter.
This is a demonstration of Wirecast.
The Jelani is the second case. So reason to make it is was to help students at the Art Academy make their homework for sound design classes. So we'll see about that a little later. One more thing is an envelope, which gives you 4 controllers.
This is a demonstration
to
of
determine
Wirecast.
how long a sound takes to decay, to die off. So if you press a key, you might want to have it take a longer time to rise up to a certain amplitude, and when you release it, there's the release time. You might want it to take some time to decay. The modulation, I'm talking about modulation here, or as we implement it, is more phase modulation.
This is a demonstration of Wirecast.
It's kind of alike, so actually FM synth is a phase modulating synth, but that's implementation. What you can see here is that if you start with a sine wave and you turn up the modulation so it could modulate itself, it would read a certain index, and it would
This is a demonstration of Wirecast.
To where it's reading the next time. So if you take a sine, during this first quarter part, it will go through quicker, and then here it will go through slower, which is exactly what you see here. So the result then is kind of almost a sawtooth wave. And the nice thing about FM synthesis is that you can dial this up and down, or you can have it vary over time, and you can make, from very simple elements, namely sine waves, you can make really interesting sound. And operators is inside an FM synth. So let's say this lane is one operator, this is the next, so we have 6 operators. That's a way of saying
This
This
is a
one
demonstration
button
of
that
Wirecast.
can modulate the next, and the second can modulate the third. And here is the matrix controlling which one will send its data into the readout index for the modulated or the carrier operator. That should be that. What do you need to build a synth or an effect? In this case,
this is a demonstration of Wirecast.
Not a long list. You need a C++ compiler. I would advise to use an IDE as well. You can download the JUCE library, which is free for open source. And if you want to make something open source, you can use it for free. And it would require some DSP knowledge, like the basic layout of FM synthesis, like I showed you
This
before.
is a demonstration of Wirecast.
Or just a general idea of what you want to make. Practical case is Jelani. I would like to show you some of the structure of the synthesizer, and I will draw it on the board. There's different classes, so like I said, the operator.
This is a demonstration of Wirecast.
It would go, that generates a certain wave that will go through the envelope. That, well, makes the loudness of the wave vary over time. And then, of course, you have, of these things, you have 6 of them.
This is a demonstration of Wirecast.
Computation, somewhere in between, in a kind of feedback loop that will do the modulation.
Is there a reason that you picked the number 6? Is that
No, I actually made a constant somewhere at the beginning of one file that I can compile it for 8 or something else.
Yeah. It's like 6 gives good results.
No, it doesn't even. Sometimes you can make something really cool with 1 or 2, but yeah.
This is a demonstration of Wirecast.
4, some at 6, some at 6 with some different operators next to it, like a special filter or noise generator. And so, yeah, for now it's, yeah, that's the choice basically.
The very first commercial FM synthesizer was the Yamaha DX7.
Yeah.
And that one had 6 operators.
Yeah.
It had FM synthesizers, also the LPL chip.
This is a demonstration of Wirecast.
So 6 like the gold standard.
Yeah, exactly. And so one other important part about these operators is that you can vary the ratio. So okay, let's say you strike one key, there's a certain frequency that goes with that, right? So A4 is 440 Hertz. Then you want to each different operator to be able to.
This is a demonstration of
respond
Wirecast.
differently to that key. So even though the key says it's 440 Hertz, you might want one operator to go twice as fast or 3 times as fast, or something way in between for weird sound effects. So that is controlling the frequency as well. And suppose you have a number of these operators, the output is routed into this modulation.
This is a demonstration of Wirecast.
Which gives, with how do I draw this again? It was something like, well, with a delay of 1 sample, it will, well, you have to add these together. It will modulate how fast the next readout is going to be. So how much that will be modulated. All right. There's something
This
more
is a demonstration of Wirecast.
basic. pretty much it. Yeah, oh, of course. There's also a different dial adjusting how much of each operator is going eventually to the outbound signal, so which you can hear. Alright, little demo time. Now we'll cut down the mic for this part.
This is a demonstration of Wirecast. 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 This is a demonstration of Wirecast.